First, okay, my name is Chris Cho, and I'm a faculty member in the mechanical engineering department. And thanks for joining this 70th Senior Design Conference. This session presentation is done by the three gentlemen, Joshua Ivy, Tim Lieber, Madison Perry, and just let me introduce you briefly about the presenters. Josh Ivy, he's from the Flagstaff, Arizona. He's from Arizona. And then Tim Lieber, he's from the Grandville. And then it shows and then her family came here. And then thank you. And then Madison Perry, he's also from the Grandville, Michigan. And then he's working as an engineering intern in the Lowe's Enterprise. And then the Abodi Rodman, he's from the Cairo, Egypt. Okay, so the presentation title, as you can see, is a modular utility trailer. And then this mentor for this project is Dr. Jason Kim. He's sitting just right there. And I hope you enjoy and everybody enjoy the presentation. Okay, thank you. Go ahead.
Everyone, that's around So, as introduced, we designed a modular utility trailer. In Stratford, Nancy Perry, that's Tim Lieber, the Colorado one. So, why did we design a modular utility trailer? One thing that I noticed within the market is that many individuals that own trailers may own several different configurations of trailers. They may own a smaller utility trailer that needs something they can haul around their quads with, as well as a full flatbed type of trailer that they can drag an entire vehicle somewhere with. So we basically decided there could potentially be a consumer demand for a trailer that has the versatility to act in both areas. So this kind of versatile trailer could help customers save on storage and their costs while being able to utilize the different modular capabilities of our design.
So for our decision matrix, we decided to split the both into four of us. Josh took over the overall designs for the 2D as well as the 3D. He also designed the 2D detailed drawings as well as the cost analysis. Tim here did the dot standards and the requirements as well as the braking system and the structural simulation. Madison did the 3D modeling as well as the assembly for that. They also did the material research and selection. I was responsible for the material selection and stress analysis, as well as the suspension designs, selection, and the FEA or structural simulation.
Okay, so the general design for this took place back at the beginning of the year in September. However, the actual designing of the system began at the beginning of January. We started from the ground up by designing our frame first and then adding it. So by middle of January, our frame design was complete for the most part. After that, we started adding components to it. And in January, we had our axles and our suspensions, not only selected, but also sourced from the company that we wanted. Beginning of February, our braking system was completed. Moving into our final material selection for our frame. Midway through March, we had our wall fastening system as well as our fastening system design as well. End of March, our overall accessories were decided, things like lights and like that. The beginning of April was our final FEA strength analysis as well as our checks in terms of legality and the Department of Transportation. Final 3D print sample that is being passed around currently was developed midway through April, and today, April 19th, we are up here talking about this with you guys.
So the main constraints for our project come from the Department of Transportation. Since this project was designed and developed in the state of Michigan, we're using the Michigan Department of Transportation as guidelines. So going along with that, there's four key sort of regulations that we want to keep in mind during the design process. The first one being that
For a trailer that has a gross weight over 10,000 pounds, it is considered a commercial trailer, and people that will have more stringent requirements on it. So we want to stay below that for our trailer. Also, low security requirements. So anything we put on top of this trailer has to be safe, not only be taller, but also on the road with the trailer. So we have to be sure we have multiple mounting points for chains, tie straps, anything like that. Also, for trailers that are more than 3,000 pounds gross weight, they require either electronic or hydraulic brakes. So in our full configurations for the trailer, it will be much higher than that. So we have the brakes on the rear section for the trailer. And lastly, we need obviously the taillights and stuff like that.
So beginning with our frame development, development of the frame took place in 3 different steps. Our first iteration of it's up here. General concept was tube steel wrapped around with a series of cross members running through it. The main changes that we made to our frame were either reducing the amount of cross members. That's how we got to the second iteration. We just adjusted the spacing from 12 inch to 18 inches. And then the final iteration takes that same 18-inch spacing for our cross members, and then our geometry was adjusted, going from square tube to rectangular. All concepts though involve a 7 by 8 foot front section with an additional 7 feet by 10 feet that would be added on in the rear. With center extrusions in the middle and on the outsides for support and attachment. Within adjusting our cross members, we have to balance weight, cost, and strength. We don't want our trailer to weigh a ton because it has to be towed, and the less it weighs, the more the lower. However, it needs to be strong enough to hold whatever you put on it. And because this metal has to be sourced, it costs too much.
So part of our design and process here was to develop a construction package for someone to be able to sit down and actually assemble this with different material call-outs or different dimensionings. Basically, we wanted to be able to hand this off to some fabricators such that they could sit down and build the entire trailer to then be used and sold on the market. So we have some number of different assembly drawings and general AutoCAD 2D layouts within our 3D model as well.
So we narrowed it down to a final model for our frame. We constructed out of our AISI 1045 overall steel with a 6-inch square tube steel outline. Once again, a 7 foot by 8 foot front section with our 7 foot by 10 foot rear section. It's going to be comprised of 12 3 by 4.5 inch rectangular cross members spanning it, with 13 3¼ inch by 1¼ inch by 12 inch tall wall mounting fixtures surrounding the outside. We also have 2 separate sets of extrusions in order for fastening. Our 2 main ones in the middle are supposed to prevent any vertical displacement, bending, things like that. And our set of extrusions on the outside are supposed to prevent torsional displacement and twisting. And with our materials selected, we've estimated through Solidworks the total weight of this frame come to about 100 pounds.
So for our next process, we did the MPA, the Finite Analysis, using the suite Solidworks Simulation. We're going to run it into different multiple frameworks since we started. We had to exclude the suspensions and walls frame just because it wasn't working. We wanted to find more safety factor using the frame. We used 4 different possibilities for the frame. For which one would give us the worst possible scenarios, and these would be explained in the next. So getting into our MPA, so we have up first our distributed load, which has a evenly distributed 8,000 pound weight across the whole trailer. On the top right, we have our displacement. Top right, top left is our displacement. Bottom right is so you can see in this placement that it looks pretty deformed. It's going to definitely into a scale of 75. It's just to give a illustration as to what illustration as to how this system works with the forces applied to it. Also, since we want our field to be rated for 8,000 pounds, we put 8,000 force on it. That's not including the weight here, so we reached a rating higher than the actual weight we put on the trailer. That's just due to the weight of the trailer. And you can see on our spring points to the field were the suspension brackets, so on the front. And then here's the front load. So it's all the way in the front of the trailer, this displacement and stress. And then this is the basic optimal, the worst case scenario where we have all the way in the back. That's not optimal because we'll have a lot more force on our pitch, and that leads to handling problems and also possible detachment of the trailer. And then one of our most optimal nodes is the center load where all these forces can be center of the trailer, and then this other weight above our wheels.
So as I touched on earlier within the construction package, we have a number of different materials that we will end up sourcing out from different vendors. This includes our axles and leaf springs, which you can see here. Those are being provided from a company called Dexter Axle. That is a pretty common axle used within some of the field work we had done, as well as a pretty reputable source for the suspension. We customize our front suspension here, which we have details for that can basically help assemble that. Some of the parts that we're sourcing, such as the draw latches, the different pins for securing the cross members and securing the structural beams are included, and we also have our hitch balls and leveling jacks that we will be sourcing from with Msrp.
So looking at our fastening system is going to consist of two main components, with our main strength coming from our series of draw latches. Those are going to be fixed at the seam of both portions of the trailer, as you can see right here. Each of these draw latches from Msrp is rated for 8,900 pounds each. And because the main gross weight of our trailer is planned to not exceed 8,000 pounds, each of these latches individually can put up with that linear force. But because we're using a series of two of them, one on each side, totaling almost 18,000 pounds of strength, these will be our main fastening system, both pieces of the trailer. So our redundant emergency system is going to be a series of two of these lock and clevis pins. These will also be sourced from the Msrp. These will be placed within our center extrusions underneath the trailer, seen right here. We were unable to find specific manufacturing specs for these. However, due to their geometry, due to them being towing rated, as an emergency system, we have confidence that if something were to happen to one of our draw latches, we would have certain amount of time released to hold the weight of both sections of the trailer at the 8,000 pound level.
So one thing that we've done early on was going and doing some field research within different trailer companies. We had gone down to a trailer manufacturer down in Vicksburg to take a look at some of their different configurations. Those configurations we got some measurements off of, helped us be able to determine where we were going to place our center lines of our axles. This was important because we wanted to make sure that our weight distribution would be a safe manner when it came to even a fully loaded vehicle hauling trailer. So this research basically got us to the conclusion of a general rule of a 60-40 split between the front and rear section of the length of the trailer based off the axle location. So basically you have 60% of your length here such that you can have a more weight loaded onto the tongue of the trailer and onto the hitch versus having any sort of load pulling onto the rear end here that would cause handling issues as we haul the trailer. Our front suspension that was selected was for an independent coil spring suspension. This we decided was going to be a little bit more ideal because it would be more versatile for the ability to take it more places, as well as just the lack of need that we didn't have to have it be high load bearing in the short configuration of trailer. So basically cutting off right here, have the suspension, front suspension, coil springs here. This would be ideal for the front section because we don't have to remove the braking system, don't have to load it very heavy. We can remove the wheels easily and basically be able to switch to the larger configuration with leaf spring axles. The leaf spring axles, the leaf spring suspension kit with solid rear axles will be significantly better for the heavy load bearing capability of the trailer. These hold, I think it was 4,000 pounds per axle, which gets us to our 8,000 pound load capacity for the gross vehicle weight rating on those. Those dual leaf suspensions are spaced about 33 inches apart and will also include a braking system. That braking system is required by our DOT standards that we had done research on. Basically, once we exceed the weight rating of 3,000 pounds, we have to start worrying about onboard braking.
So the next element of this trailer is going to come our readable walls. This is a very general concept kind of shape for what we imagine kind of walls would look like. They're going to come in 3 foot and 6 foot heights. They're designed not necessarily to be load bearing, but to be more for containment. So if you have your 3 foot walls and you have your trailer set up in the short configuration, and you put a couch on it, the couch is sliding around in the trailer, the walls can withstand it, but significant amounts of force on the walls are not recommended for a vehicle. You know, 1x6 inch planks running with a 12-inch spacing, 3x1 inch tube steel running for each of our posts. And for our side walls, these are each been spaced about 4 feet apart. So looking at our fastening system, as I said earlier in the presentation, we have 13 of these 3.25 inch by 1.25 inch by 12 inch mounting fixtures. Those can hold 12 inches of our wall, the wall post fitting within them. These aren't load bearing walls. However, because this is 12 inch tall, it's going to hold enough of that wall in where it can withstand certain amounts of force that could come from the load sliding around with the trailer. They're going to be fastened in place with a series of these half-inch quick release pins located about 9 inches up from the bottom of the fixture. And on the sides of our trailer, our brackets are going to be spaced 4 feet apart.
So for our next was the rear gate for our end of the trailer. We added a fixed individual strap hinges just to fasten the hinges at the back of the rear end trailer, so it's permanently there. Also to allow people go up the ramp without any issues. We also had a sliding system for closing just in case anything doesn't tip off the end of the trailer. We also had a 5 foot fixed height to act as a ramp for our HEV to move up onto the road trailer.
So since the main scope of our project was designing the frame and the structural elements, so we did not create a electronics diagram. We did come together with these parts or components that would be required for the trailer to function properly. So the aforementioned tail lights on both the front and rear sections, any clearance reflectors or lights on the corners. Also, we chose electronic brakes, and this will need to be on the rear axis because the brakes are required in full length trailer configuration since they'll be rated for higher weights. Also, we've disconnected between the sections so we can easily hook up the wiring to the back trailer section to the front, but then into the vehicle. Also, since the trailer has electronic brakes in the configuration, it also requires a breakaway system. The breakaway system is essentially a cable that gets tied to your vehicle that goes into a switch. So if the trailer comes separated from your vehicle, the switch will get pulled and the electronic brakes will fire to prevent your vehicle from being absolutely on the road. And also, a electronic brake controller for the towing vehicle is recommended because this is rated for high gross weights to extend the life of your trailer or your vehicle brakes. A brake controller is recommended to help gradually apply the brakes and just be on.
So we also added the tail lights at the back there for the front and the end of the trailer for stop and turn signals, as well as the link deck right here and while the trailer will be up and down with a deck board, purpose of wood, just in case this is not that many packaging methods or doesn't have that roughness, as well as the tumbling hitch coupler, for flying and stuff. And,
So looking at the list of all the possible configurations, all the possible things that can be done with this, we can start with something simple. We have our short section of the trailer with our 3-foot walls on it. This could be for furniture, small ATV, a couple yards of mulch, yard work. The walls can be taken off, and you can have your class section right here, complete with its own axles and its own tail lights for strapping down a small ATV, things of that sort. If needed as well, you can add the extra 10 feet on the back of it with the rear gate. And based on our dimensions, our measurements, our calculations, we wanted to be able to fit the biggest vehicle possible on here that we could. So based on the geometry of this and the weight ratings, you could put your mom Chevy Suburban on the top of this if you wanted to. ATVs, things of that sort. You could add your 3-foot walls and contain it, or you can add your 6-foot walls as well. So it's imagine this product would be sold as the full assembly, most likely in this configuration, with your 3-foot walls coming with that as well. And there'll be some sort of owner's manual or booklet listing out all of the sorts of parts, such as your draw latches and clevis pins, your Breakaway pins, things like that. In case something goes wrong with one of that, instead of go through us as the manufacturer, you can go straight to the source. So McMaster Cars.
So here you can see our general projected project budget for this, including pretty much all our materials and most of our specialized equipment and source parts. The budget we ended up coming down to ends up sitting just shy of $7,000. It does not include projection labor costs or basically the labor costs or even our projected market value. But this is just our straight material costs alone and what it could cost overhead to basically assemble. Our estimated market value of this trailer sits greater than $12,000 based on some of our field research of determining basically some of the trailers that are being sold over at Premier Trailer at similar weight ratings.
Anybody has a question? Austin? Go ahead.
Okay, so we have open the floor for any type of questions. I guess they're ready to answer any type of question, whether it's a technical or non-technical.
I'm curious why the 17 feet, why a 7, why a 10? And I noticed your slide talked about the removable wheels on the front half of the trailer section. So I don't know if you want to expand on that a little bit more, but do you take the front wheels off and you put the back section on?
So yes, we would take the front wheels off and we put the back section into place. We did that because basically the turning radius would be problematic as you sit there in the round corner with those front wheels on. And what's the first part of your question?
Why 17 feet? Like, park trailers are typically 18 feet, so why 17?
So we chose 17 feet based off of was basically there was the size of the Suburban, of course, but there's also the easier method of locating our axles within the weight distribution study. So with 18 feet, we're going to start having a little bit different of a distribution on those axle locations. And basically 17 feet I found to be ideal.
What is 18 feet? 7 feet wide.
17 feet wide.
8,
yes. 8 to 10.
I guess my last question is, so you say about $12,000 to the MSRP, right? So how does that compare, like, the last trailer I bought, $10,000 per trailer, $5,800. So it's half the cost of your trailer, so how do you...
So the projected cost that I was looking at was based off of 8,000 pound low capacity platform car trailers. So I don't know what kind of trailer you purchased, but generally what my weight rating or my estimate off of that was based off of similar market type trailers and kind of matched towards our full configuration on that. We matched towards like our full configuration in the platform setting. Right there. Yeah, the premier, where we went for that was premier custom trailer for those estimates as well. And those were like 1 to 2 year old trailers as well. So the trailer we purchased, maybe it was used an older trailer, or whether it was a brand new off the lot trailer.
I was just curious.
Okay, I think there was another question.
I was just gonna ask the MSRP on full trailer. Yeah, the MSRP was 12.15. It was in many, yeah, without the module. Without modular capabilities.
Okay, any other question?
I have one more. So the latch, all latches are like rated for 800,000 something?
Yes.
Did you do that analysis loading the trailer like this, or like, you know, when it's hooked up to the truck and you pull away, like that's the loading? Efficiency did both ways.
Yes. Yeah, like the linear force for that, as well as we have of course our right. The extrusions are going to be the vertical aspect, so supporting that, but those would be the linear forces, as well as of course our redundant cleavage pins that we have for the safety support of towing pins.
Any other question? Oh, I guess a quick question for you. Usually in the front tongue sections, you have a triangular beam.
Yeah.
And then typical trailers, so the beams are going underneath, and then you just weld it on the front, whatever beam. I'm just in front section. And then I just assume that I'm irritating of the load on the welding sections, but I'm just curious. So what are the differences between welding to the front beam, or the other ones are beam sections going all the way? About quarter of the whole beam section.
So you're referring to like the tongues that actually
No, I'm talking about
underneath.
trailers. If you see the front, I mean, I'm talking about this section. It's underneath and extended.
Yes.
Where they find at the point. Does it actually compare?
Our tongue is more representational within that as well. So we could run with an option like that. We do have the ability and the space to do that type of option within the design of the top.
So when we ran our analysis on the forces, we didn't see any stress concentrations around the plane. So our initial design was just brought it on since we didn't see any problems or any sort of red flags. So we considering that.
So we didn't stay. Okay, any other? Right, I think